Hello, it's a pleasure to have you here watching this video. So today I am going to be walking you through how to build a tipping smart contract in Solidity. I find this is important for developers to learn how to interact with tokens via their contracts, right? Interact with any ERC20 token because this is useful when you do not just want to build a contract where you have to use the native token of the particular blockchain you're interacting with, for instance Ethereum. So typically your tipping smart contract is useful amongst many other use cases for people who want to set up a system of they set up their own contracts where they can take tips without having to use any other form of escrow contract or use any of the other solutions out there, right? Or even use traditional banks. So basically, every developer has the way they start out their projects. Some prefer diving right into their IDE and start coding. I find out that it's great for you to think about what it is that you want to achieve. See as many steps that you can break it down into, and then it gives you an overview of the general results, right? So since we are not going to be building out our UI in this session, I'm just going to do a walkthrough of what our contracts look like. It's a very simple smart contract, right? Typically just has 4 functions that we are going to write. You can see on this side here we have a bunch of users interacting with the contract, and then this is the contract owner, right? What we want is to be able to every user should be able to deposit tips, right? So that means we're able to receive tips. So that's a function in itself. And then we are able to withdraw these tips and then check the balance of tips that we have in the contract at every point in time. And if ever we feel like changing the address that we are using for the owner, we can actually do that, right? I also have an article that I have written regarding this that I've published. I'm going to be sharing the link in this video as well. So typically when you have this contract and you have all of these functions that we have listed out, that means in order to really follow along with what is happening with our contract, it would be nice to emit particular events that possibly in our UI we can take these event logs and then display it on some kind of dashboard, right? So the events that are really critical here whenever a user action changes the state of the contract, we want to know when we have received a tips, and then we also want to have a log of when we made withdrawals on tips. So having said that, we are just going to jump right into Remix, which I already have open here, and then start writing our smart contracts. Remit by default comes with a bunch of example contracts that you can always look at and then learn it 118 or 2. You can see here that I've already created an empty file where we are going to be writing our contract, right? So we have an empty file called tips.so. So like I said, every developer has a way that they begin writing their contract. So basically this contract it's going to enable us. I think the biggest takeaway for developers is you're going to learn how to interact with any ERC20 token contract, right? And then what we want to do is to start writing our contracts, but we are going to need an ERC20 contract to interact with, right? Which we are going to deploy here as well, and we are going to be using OpenZeppelin for that. But first, let's start writing our smart contracts. Of course, we begin with our license identifier, right? I hope I spelled that right. Identifier, and then we're just going to use MIT. I find out that as you're building out your contracts, it's just easy to run a save so that if ever a point that you have an error, you'll quickly catch it. So we are going to be using, just written our pragma statement, and we're going to be using Solidity version 8.19, which is the latest stable version, I think. Let's check that our compiler is set to version 19. Oh, okay, there's version 20 now. So you can quickly compile this, and you would see that it's taking a while, but it's definitely going to compile. So we're just going to keep writing the rest of our contract. We're going to be calling this tip, and then open up our contract. So that's not compiled. Yeah, so it's successfully compiled, but there's no contract in there yet. So now we have an empty contract. That statement should change. So that is our contract right there, that is compiled, tip.so. We can actually deploy this right now, but there is really nothing inside there. So like I said, we are going to be having 4 different functions, right? The critical function here is the ability to be able to deposit tokens, right? So in as much as we are going to be able to deposit tokens, right, and then we want to not interact with the native token, but rather want to interact with any ERC20 token, we'll just go to open Zeppelin, and then use the contract wizards to come up with an ERC20 contract, right? So that is loading. So this is the Open Zeppelin contract wizard. As you can see, you can have an ERC20 token quickly spawned up. If you want any other, this contract to have any other features, possibly you want to make it an upgradable contract, right? You can add that, and then it adds more libraries and then makes it upgradable. But we don't want that. We don't want upgradability. We just want a very simple contract that we can use. Do we want to like pre-mint it? No, but yeah, it has to be mintable. And then I think that's about what we need for the contracts, right? So you have your constructor. You can call mint and mint to any address, and then it has the access control where it sets the owner. So we can copy this in Open Zeppelin, right? Go back to Remix, open up our files, add the new file, and just call it my token.sol, right? So paste that. Yeah, this is fine. And then let's set the compiler, the version of this contract to 19, so that's to run on the compiler, right? So that's successfully run. So we have the token there. We can deploy this token, and then we have every thing that we need for the token. We have the name, which is my token, symbol MTK. Right now it's 0 because we have not minted any, so we can actually mint a couple by copying the address, paste it there. Then let's mint 1,000, right? So we transact mint 1,000. Now you can see that the total supply increases to 1,000, right? So we have our token set up. So next we are just going to go into our tips. So basically for this contract, a couple of things are important, right? We want the ability to be able to interact with any ERC20 contract, and the way that we will be able to do this is by interacting with an interface of an already deployed ERC20 token contract, right? Interfaces make this possible in Solidity, so that way we don't have to like take a copy of the contract and then have to like deploy it and then be able to interact with it. So that way we can use the interface argument, passing the contract address, and be able to interact with it. And thankfully Open Zeppelin again provides us a library that we can use to interact with any deploy token, right? And then it gives us all of these functions available for us to interact with the token. So what we want to do is we want to import the Open Zeppelin library, right, at the top here. And then also we are going to be carrying out a couple of transfers during the course of interacting with the contract, right? We are going to be taking permission from the user's wallet and then be able to access it and conduct a transfer. So I find it easy to use the safe ERC20 contracts to be able to do this. Why? Because whenever the operation fails, we'll be able to like get the correct response when we go into our logs. So let's take this, copy it, add it on here, right? And then again, it is very critical that this contract is only controlled by a particular owner address, right? And we can actually write a custom modifier for that. But as against doing that, thankfully OpenZeppeli provides access control, right, where we can go into the APIs, go to access control, and then where we see this enable contract, right, that enables us to set the owner of the account, the address that deploys the contract will be the owner, and then we'll be able to like make sure it gives us extra features that when we set that owner for particular functions, it will just be the owner that can carry out those functions. So it comes custom with the only owner modifier, right? And then it gives us a bunch of functions that we can work with. So it sets an owner for us. So this means that way when we are writing our contract, we don't have to like indicate message or sender address as the owner, and then it checks for us the owner. So this function comes by default. Though if you want to like interact with these functions from your front end, you would have to like write a custom function to wrap around these particular functions and then be able to interact with them. So you can renounce ownership, transfer ownership. And then we are going to copy this library and import it into Remix. So now that we have said that, basically since this contract it's going to be undergoing control, so we have to indicate that it is ownable, right? And then save it. We are still no errors made here. It has successfully compiled. In the course of writing the contract, like I said, we have a couple of functions, right? And we are going to be interfacing with the interface of a deployed ERC20 contract, which is why we are using the OpenZeppelin IERC20 contract, right? So, and also we are using the safe ERC20 to be able to like interact with this interface. What we want to then do is that we want to indicate that we are using safe ERC20 for the interface IERC20, right? And then we already deployed a token, my token, because everything that we are going to be doing, it's inside this Remix environment, right? If it is an instance where we are building this contract and then it was going to go into production to be used with any other token, we can build it out and then not have to like indicate a particular token that we want to use. We'll make it as available to every ERC20 compatible token, right? But in this instance, we are going to be using a particular token that we want to like deploy in our constructor as well. So what we want to do is indicate that we are using IERC20 20 to instantiate a token and then set it to ERC 2020, right? So this shows that we have a token that we want to like pass into our contract so that we'll be able to carry out other other methods on this token. For instance, safe transfer form, which we actually going to need for the rest of our contract. So we can go ahead and write our constructor, right? Our constructor, we take one argument, right? And that is a token that we want to pass to it, which was my token that we already deployed. But we have to indicate the data type for token. And your guess is as good as mine when you say that if you were to say that this token is an address, that would be wrong. You have to indicate that it is of an ERC20 type and pass it in by the interface, right? So as you can see, that still compiles. If you had, specified the data type here as an address, that would be correct, but the challenge now would be that when you pass it to token, right, because we want to deploy this contract and indicate the particular token that we want to be interacting with, right, this is going to fail because you cannot assign address type, right? You cannot assign address type to ERC20, to an interface type. So we have to fix that. We have to fix that, indicate that, right? ERC20. So all errors are gone. So now we can go ahead and start writing the functions that we need for our contract. The first one is the function to receive tips. Function to receive tips. Now, what do we want this function to do? It's very simple, right? We want it to be able to receive tips from any users, and what that means is that it has to first of all be public, right? And then that also means that because it's receiving token, it has to be payable, right? So we can decide if we want to add a return statement to it so that when we are going through the log, we'll be able to ascertain if it's does what we actually want it to do. And in order to do that, that means we are passing in an argument to it, because this receive tips is actually going to be changing state, right? So what we want to receive is a particular amount into this contract, and then we can indicate this variable amount that we are going to be passing into the function. And then we also have to set the data type, and the data type here for this, we can set it to be an unsigned integer to 56 bits, and we can say that this is payable, and it also returns an unsigned integer, right? So will you save? I always suggest to save at every step you go so that you can catch errors as you add more logic. So now our contract has to be able to receive tips, right? And what we want to first of all check for is to make sure that nobody is trying to send anything less than 0. So we can then indicate that we want to make sure that our amount that is being passed in is always greater than 0. If that is not the case, send an error message to the user that amount must be greater than 0, right? So that's a require statement to check there. So, and then the next thing that I want to do is be able to like do a simple transfer on the user's token. But get this right, because this is the critical learning point here. If anybody has a different way of doing this, please do kindly let me know. But during the course of building this, I discovered that it is easy to do a transfer from the contract, do a withdrawal from the contract to the owner of the contract, right? Using safe transfer, as against approving the wallet address of any external user who wants to like deposit into the contract. Because why? They have to carry out an approve first for the particular token that they want the contract to spend. Let me pause and say that again, right? So we have our contract, and then a user needs to deposit into the contract. But to be able to deposit an ERC20 token into the contract, the user first of all has to approve that this contract is able to spend their tokens, right? So typically you might think that although I really don't know if there is some other way to do this, but my first approach at doing this was to first of all call an approve method on the token, because if you can see here, for the token that we are going to be using, right, you can see that there is an approve method, right? And I figured since we are going to be interacting with the contract via an instance of it via the interface, right, and the approve only requires you to set who the spender is and then set the amounts that you want the token to spend, as long as your wallet calling it. So I figured that if you call approve, right, and then set the spender as the contract, which will be address this and passing amounts, I did discover that this is not going to work, right? To complete this so that we don't have any error, let's specify what we are returning, and that is amount, right? To demonstrate the error that I experienced when I got to this point here, right, let's just deploy this contract. So we already have my token deployed, so we are going to copy that address because we are passing it to the tips token, because we want to like be able to receive tips from this particular my token right now, which is an ERC20 compatible token. So what that means is that if you wanted to like be able to receive just tips in USDT, you'd have to like pass in the USDT address when deploy this contract, right? And then let's do that, deploy it. So we have tips right here, right? And tips here, the owner is this same address, right? We haven't specified its ability to receive, we haven't specified its ability to check this balance, right? So but what we want to quickly test here so that you see this error, it's the ability to receive tips. So typically we have said that the token here is approved, right? And then without even calling safe transfer from yet, right, if you call tips and say you want to like pass in 100 of my token and then call a transaction, you can see that that transaction was successful, right? But on further inspection of the log, right, you find something interesting. Right? You would see that fine, it decoded the input as 100, but in the particular logs, the event, it's actually an approval event, right? From the contracts, the call came, it recognizes the call as coming from the token contract, right? But the argument here, it specifies the owner as the contract address and specifies the spender as the contract address and passes in the value 100. But meanwhile, In interacting with ERC20 tokens, where you have to like have an approval, right? Here in Open Zeppelin, where you call an approve event, right? So basically, when you call an approve, you pass in the address of the spender, which is the contract in our case, and the amount, like I said. But the interesting thing is here is that it emits an approval event, right? And the approval event which it emits, it's right here. It's supposed to specify the address of the owner, address of the spender, and then a value, right? So the address of the owner in our instance here, it's supposed to be this, EOA here, but it specifies the wallets, the contract address as the owner address. So just to further express, why this would cause problems, is that if you call save transfer from, right, which is the method that we are going to use to like interact with our contract, right? Save transfer from, we are supposed to be able to transfer from the EOA into the contract and specify the amount, right? So you can do message dot sender, right? Address this, which is the contract address, and then you specify that I want to like transfer the amount that we passed in, right? Put your semicolon there so that we don't run into any errors, but this is already looking like it's going to fail because we have too many brackets. So yes, that closes that. So yeah, save that compiles, and because we have compiled a new contract, this means that this contract, it's no longer valid. So you can delete this, copy my token contract address, deploy a new contract of tips. So tips is available here. Yes, what you want to do is receive tips, but this is going to fail, right? If you transact, you're going to fail and return an error, insufficient allowance, and that is because the insufficient allowance, right? And that is because the approve message is failing, right? That's because the approve message is failing, so it returns with the message insufficient allowance. So the way I was able to work around this is to interact with the ERC20 token, right? And I'm going to show you, then I'm going to explain how you can do this via the UI, right? And also definitely I'm still going to like make a video on that, right? So what you want to do is go to the contract itself, the token contract itself, right? Copy the address of the tips contract and then call the approve function, because what we want to do is like you want to approve that contract to be able to spend an amount of your token, right? So you call transact, so that is successful. You can then see here that when it emits the approval events, now it sets the owner to be the EOA, right? The EOA OX5B3, which you can see here, and then it sends the spender to the contract address, right? So then when you call receive tips that you want to like send 100 of my token to receive tips, if you call transact right now, then it passes, right? So we have successfully sent 100 of my token. So you can see that because we still have the approve method in here, it emits an approval event, it emits another approval event, right? But the interesting thing right now is that you can see from these approval events, which is in the contract, it still sets the contract contract as the owner, the contract as the spender. But this is the one from the token. It's, you know, sets the owner as the EOA and then the contract as the spender. So, and then we are able to successfully transfer, right? So it has transferred from the EOA into the contract, and it has transferred 100 units of my token. So we can continue writing this contract. First, we're going to remove this approve method here. You know, compile this again, save it, so it compiles. And now I'm just going to give you a brief explanation of how you could possibly implement this when you are building out the UI, right? Because when you deploy an instance of your contract, say you are building with hard, right? So what you then want to do is that when you are building out your UI, and then you have set up your wallet connection using maybe Ether.js or Wagmi, right? You want to call a method that takes the ABI of any contract that now you want to interact with, say USDT, right? You take that ABI, and then you are able to access the methods available in that particular token contract, and one of those methods is approve. So that way, from your UI, you are able to call the approve method and approve, you know, a token spend for that particular token for your contract to be able to spend it for the user. So that way, when the user triggers their MetaMask wallet, they first of all have to like approve your contract to spend their tokens, and then now have to like approve a transfer again, right? So I hope that makes sense to you. But like I said, I'm going to make a video about that as well, explaining how it works. So we'll go back to our build, and seeing that we can, you know, basically transfer token to our wallets into our contracts, right? What we then want to do, like we said when we are showing what our build is going to look like, is that we want to be able to like emit events. So we want to be able to say that our contract has received a tip, right? So you can come up here, specify your event. So we are going to call this tip received, right? Our event is going to take I think our event is going to take, for tip received, it's going to take 2 arguments. We are going to have the sender, right? Let's call this sender address, and then we are going to have the amount. So but in here we have to specify the data types, right? So this is an address type, and this is an integer type, an unsigned integer type, right? Oh, sorry about that, an unsigned integer type, right? So we want to like emit these events before we get to our return statement, right? So we want to say emit tip received, and then passing the 2 arguments, the person that is sending the tip, which in this case is mentioned as sender, and the amount that is sent. So again, save that, and you can see that it compiles. So the next thing that we want to be able to do is I think before we're able to withdraw, let's check the balance of the particular token that we have in the contract, right? So we can call that function, let's see, get token balance, right? Token balance. This doesn't have to be public, right? It has to be only the owner that can call this, and that is where access control comes in. So typically we would have written a custom modifier for this, but thankfully OpenZeppelin has already given us access control, so we can just specify only owner modifier here, right? and then that means it's not public. Well, even if we decide to make it public, only the owner will still be able to call it, right? So basically we can set it as public, but only the owner will still be able to call it. So this does not take in any arguments, right? And because of that, it's a pure function, because it just returns only what it holds. So we can set it as view, and then we can add a return statement, right? And we say this returns returns an integer, right? 256 type. So what we want to do is that we want to say that it should, we want to pass in the token, and then the token method provides us a method called balance of, right? So I want to check the balance of the contract. So we can say token balance of this particular contract, right? Address this. So just since we are having a return statement there, so just add the return in here. So save that compiles. Let's go test this, right? So that means we have to like delete this last contract here that we deployed. So to deploy another contract, copy this, pass it in here, deploy this, right? And then deploy that. So like I said, if we just go ahead to click on receive tips, we'll get an error. So you first of all have to call and approve this contract to spend the tokens of our EOA. That's the old contract address here, passing the new one, right? So that has been approved. Now receive tips, let's just send in 100, right? So you can see that here we have get token balance, right? So if you check the token balance for this contract now, it returns 100. So now that we're able to receive tips, get token balance, the next thing that I want to do is to be able to withdraw. And this is where it gets interesting, because as against being able to receive tips where we have to go call approve inside the particular token that we're interacting with, but with withdraw we don't have to do that. So we can say function withdraw tips, right? We want to specify that this is public, but only the owner is able to call it, right? Because we don't just want anybody coming and then withdrawing all our tips, right? And then we don't want to withdraw everything every time, so we can specify an amount I want to withdraw per time, and then we want to like set the data type, right, as an unsigned integer. So only owner. Do we have to use the require statement? You can if you wish. So you can simply copy these out and then paste it on here. You do not necessarily have to write. I mean, because for every call, having the require statements and having so long a string for the error message could increase, the cost of interacting with your contract, but that's fine anyways. So yes, that's it about the require statements, right? And then what we want to do is to be able to like carry out a transfer, right? So the beautiful thing about transfers here is that as against when we use transfer from, when we are receiving tokens into the contract, where we have to specify the address that we are sending to and the address that is sending in. Here, all we just have to do is pass in the token interface, right, and then do a transfer, right? And then the transfer, you can come to the Open Zeppelin docs, look at the interface and see all the functions available, and one of them here, it's the transfer, and then it just takes into arguments just who you are sending to and then the amount, right? So we are going to pass in the to as the message.sender, which is of course the owner in this case, and pass in an amount, right? And then we are going to return amounts. So in order to return amount, yeah, it's return, okay, sorry, semicolon here. In order to track the activities that are happening, in this contract with this particular function, we can decide to add an event, right? Just as we have tip received, like we indicated here, we have two events for tip received and tip withdrawn. So we're just going to add another event to tip received, call it event tip withdrawn, and all we just want to pass in, it's the amount, right? So you can say, you can ask for it to emit tip withdrawn and then pass in amount, right? So that's done for that. So we can go ahead and test this out, deploy another contract, right? Deploy, that's our contract there. One thing that I wanted to test earlier that I didn't get an opportunity to, but here it is, you can see that the token balance is already 0. If you want to like receive tips, say 100, it's gonna return an error. So what we want to do is first of all approve this token to spend my token, remove the last contract address, put in a new one, right? Yeah, that's successful. So now receive tips 100, that's successful. So get token balance, that's 100 in there, right? So we want to withdraw tokens, so let's withdraw say 50, right? Before we do that, it's still we minted all of our original tokens to the address that we've been working with. So by now I think our token supply has really reduced. Oh, that's the total supply in circulation. Let's check the balance of the address. Let's see how much is left there. Oh, 685. So 685, if we should withdraw 50, that should bring us to 735. Yeah, yes. So that was successful. Now let's see what is the balance. Yeah, 735. So, and then what is it, how much is left in our contract? That should be 50 left. Yeah, 50 left. So all of that works, right? We have been able to like build a TP contract, written out our functions for receiving tips, for getting token balances, for withdrawing tips. The last thing that we would do here would be to like change the owner. So like I said, Open Zeppelin access contract provides the ability to, transfer ownership, right? So you would want to write a custom function to wrap around that, right? You can either do that or in your UI, with the from your instance, you can write a method to be able to like do this, right? So there you go. Thank you very much if you stayed to the end of the video. This is what I hope to be first of many. Yeah, we'll see how this goes, and we just keep making this. Please, if you have any feedback, kindly let me know. If you figure that there's a way that this could have been done better or differently, please do kindly let me know. Thank you very much for watching to the very end. See you in the next one. Bye.